Statistics is all about data. Without data to talk about or to analyze or to question, statistics would not exist. There's a story to be uncovered behind all data, a story that has characters, plots, and problems. The question or problems addressed by the data in their story can be disappointing, exciting, or just plain ordinary. Below are 3 types of data displays: a dot plot, which is plot A, a histogram, which is plot C, and a box and whisker plot, which is plot B. Determine which of the graphs, if any, apply to each statement. So, here, it says, let's see, number 1 says the median can actually be determined. So, with this, I would definitely say plot B, because we know our median is that vertical line in the middle of our box. That kind of separates your data. So I would say for sure we can find it in plot B. The median for plot C we actually cannot find because we don't really know what the data points are. And then plot A, you could find the median. But again, it's going to be kind of difficult, but you can find it for plot A. Okay, the data is split into 4 equal parts. Well, the only thing that we know is split into 4 equal parts is plot B. We know that each whisker is 1 part, and then each part of our box is a part as well. So it totals into 4 parts. The graph is symmetric. Actually, I don't really see any of these boxes being symmetric, or any of the graphs. So I would say none on that. You can see all individual data values. The only one that you can see all the data values, because each point on a dot plot is a data value. So the only one I would say is plot A. The minimum value can be determined. Let's see. Plot B, you could definitely determine the minimum because you know that first point here is going to be your minimum. So I'd say for sure plot B. Plot A, you could also, because you know each and every data point. So the smallest one here would be your minimum. But with plot C, you really don't know what your values actually are. So you couldn't find it with plot C. The interquartile range can be determined. So that's from quartile 3 to quartile 1. Plot B, you could definitely find that. Plot A, you could. It would take a while, but you could. And plot C, let's see. I would say no on that one as well. Because, again, you don't have all your data points. So you can't actually figure out where any of your values are, to be honest. The median is smaller than the mean. So in order for a median to be smaller than the mean, you have to have let's see, you would have to have, it would have to be skewed. And it would have to be skewed left. So the only plot that I see that is skewed to the left would be plot C. Okay, so that's going to be the only one where I think that it would be smaller than the mean. The mode can be determined. The only one I see, again, with plot C, you can't really do much with that because you don't actually have all the values. In plot B, again, you don't have all the values. So plot A would be the only one where you could find the mode, because right here, that has the most dots. So that's going to be your mode. Which graph is the best at displaying its data? Explain your reasoning. This one's kind of tricky because it depends on what you're looking for. But I would probably say plot A because you know what each value is. So I would say plot A, but I would accept multiple different answers on this. Depending on what your explanation was. All right. Moving on. Let's see. Transportation officials collect data on flight delays. So the number of minutes past the scheduled departure time that a flight takes off. So basically how long you have to sit there and wait for your flight. So by surveying 60 big air flights during December in 2012 and displaying the data in this dot plot, we can kind of determine that like these two flights, they didn't have any delay at all. So the time that your ticket told you you were leaving, that's the time that you were actually leaving. This flight here, it had a little bit of a delay. I would probably say about 6 minutes, but that's not bad. Okay, so here, like this many flights, let's see, 1, 2, 3, 4, 5, 6, 7, it looks like 7 flights had a 20-minute time delay. Okay, and then you get up here to where like these 2 flights, they had almost a 2-hour time delay because it was 120 minutes. So that data is just kind of telling you, if you were to go to an airport and you were to get on a plane, this is what your average would be. So it says, what do you think the graph is telling us about the flight delays for these 60 flights? Well, if I look at this data, what I kind of see is a lot of our data points are over here to the left. So this would be kind of a skewed left graph. What that means is that really a lot of these people did not have to wait that long to for a flight delay. So I would say the majority of flights were on time. Or you could also say we're on time or had a minimum flight delay. Okay. Based on your previous work with dot plots, would you describe this dot plot as representing a symmetric or skewed data distribution? So we kind of already talked about this. A lot of our data is over here to the left. So if you look at this, it slowly kind of declines. So I would say this is skewed. And I would say it's skewed left if we wanted to get more technical with our answer. And you could say the reason for this is because a lot of your data is on the left side of your dot plot. Can you think of a reason why the data presented by this graph provides important information? Well, if you were traveling, it's good to know what kind of delays you might be facing so that you know when you're going to be leaving, what time you'll arrive at your destination. So that way, maybe if you were traveling for work, you had to be at a meeting at a certain time, you know that it might be a good idea to make your flight a little bit earlier than what you need so that you can get there on time if there were a delay. What is the approximate mode of the data set? So if we look at all our points here, mode is the number that occurs the most. So we're looking at this strand of dots here because that is the one that occurs the most times. Okay, so that's between 10 and 20. And if I were looking, there's a little line right here that would represent like 15 because that's in the middle of 10 and 20. And it's a little to the right of that. So I would say maybe 16 minutes approximately. Large Sky Airlines reports a mode for their delay times as 10 minutes. So does this make Large Sky Airlines better than Big Sky Airlines? Explain. That's kind of difficult to say. I wouldn't necessarily say that it makes them better. I mean, they could have a mode that's 10, but then have like most of their data on the other side, making it, you know, maybe most of their data was 100 minutes that people had to wait. So you really can't tell much by the mode. So I would say that no, this does not make them a better airline. But it could mean that they are better. It just depends. If Big Sky Airlines sampled delay times for their flight throughout the year, would it look the same as the one shown? So this is just for December. Now, if you think about December, you think about Christmas a lot of the time. So maybe a lot more people are actually traveling during that time period, which could create more delays. So you would maybe expect for it to look similar to this, but it definitely would not look the same as the one shown. Okay. Now we go on to our next example. It says the following histogram was created from a sample of residents of people living in the United States in 2010. Okay. So it's kind of saying like what percent of the people are aged between 0 and 5, and then it gives you about 6.5%. So like from here to here, you're saying 6.5% of the United States people are from 0 to 5 years old. Okay, so what do you think this graph is telling us about the population of the United States? So if you notice, a lot of our data is right here. Okay, so what that's telling us is that a lot of our United States population is ranged from 0 to 60 years old. Once you get past about 60, which is approximately right here, it steadily declines, which means that a lot of our United States citizens, 60 and above, there's not that many of them, which could be a reason for, that could kind of show where our life expectancy kind of lies. So would this histogram created from a sample of residents of people living in Florida in 2010 look the same? So this is a good question because whenever you think of Florida, you either think of vacation or Disney World or something like that. But a lot of the people who live in Florida could possibly be retired. So if they're retired, most likely they're over the age of 60. So I would say this histogram would not look the same. So no. And I would tell you because of retired people. And most retired people are generally over the age of 60. So what population of people does this data represent? So this is another good question because there's a big difference between a population and a survey. A sample. So a population represents all of the people. So if we were talking about like Alton High School and I wanted to poll maybe just, let's say just the second floor people, our population would be all of the Alton High School kids. But the sample would be just the second floor. Okay, so what population of people? That's correct, talking about the big general population. So that's talking about the population of the U.S. Okay. All right. One major thing that we're going to talk about with these next examples, and I don't really have much to write for these. I'm going to be talking a lot. So if you end up having questions on these, please email your teacher, your corresponding teacher. So it says a survey has bias. And a lot of you probably already know what bias means, but when it contains assumptions that may or may not be true. So that'd be like you guys assuming that I graduated high school with all A's because I'm a teacher. That doesn't necessarily mean that that's true just because I'm a teacher. So that would cause some bias. Bias can influence opinions and can make one answer seem better than the other. So like in debate class, you guys have a lot of this come up, because if you were to ask somebody a personal question, there would be bias there, because they might not necessarily want to answer that. So they might answer differently than what they actually believe, just because they don't want to answer that question in front of somebody that they may not know, or something along those. So survey questions must be carefully worded to avoid this type of bias. So we want to determine bias in a survey question. So for number 19, it says a reporter wants to find out what kind of movies are most popular with local residents. So the reporter asked, do you prefer exciting action movies or boring documentaries? Is this question biased? Absolutely. So we can say that this is biased because of these words, exciting and boring. I would most definitely prefer to watch an exciting movie or over a boring one. Okay, so we would say yes. And honestly, if you just underline the words exciting and boring, that would tell me that you know that those words are not okay to use. So it says, how can the question in example 18 be worded so that it is not biased? Well, you could just take those words out. You could say, do you prefer action movies or documentaries? So that way, it's not swaying you towards the exciting action movies. It's not swaying you towards the boring documentaries. It's just asking you a point blank question whether or not you enjoy action movies or documentaries. Samples can also be biased. Excuse me. For example, all voluntary response samples are biased. So what that's saying is that if I wanted to take a survey and I asked the question, but you only had to answer it if you wanted to, that can definitely be biased, because you might feel strongly about the specific topic that I'm asking you about. People who don't answer might not care either way. So because of that, they are biased, because you cannot be sure that the people who chose to respond are representative of the population. So the location where a survey is conducted can also cause a sample to be biased. So if I went to a school pep assembly and I asked everybody who was wearing our school colors, red, and said, hey, do you guys support the school athletics? Most likely that's going to be pretty biased. For one, I'm asking at a pep assembly where they're cheering for the team that they want to win, which is us. The other thing is I'm asking only people who wore red, which means that those are the people who are really supporting the school spirit and most likely really enjoy our athletics. So those are all reasons why this would be biased. So for number 21, it says you want to determine what % of teens aged 14 to 18 watch wrestling on TV. So at a high school wrestling match, you ask every third teenager whether he or she watches wrestling on TV. How might this cause bias in the results of your survey? Well, again, you're asking at a wrestling meet whether they like to watch wrestling on TV. So that could definitely cause some bias of where you're asking. And you're asking teenagers that are there. You're not asking anybody else. So there's definitely some bias there. Number 22 says you want to know how many of your classmates have cell phones. To determine this, you send every classmate an email asking, do you own a cell phone? How might this method of gathering data affect the results of your survey? So this one might be a little harder to see, but like I have my email sent directly to my phone. So if this is the case for other people, then only the people who have cell phones are going to respond to that email. So that's definitely causing some bias there as well. For number 23, it says a researcher conducted a survey to determine whether people in a certain large town prefer watching sports on television to attending the sporting event. The researcher asked 117 people who visited a local restaurant on a Saturday, and 7 people refused to respond. Which of the following factors make it at least likely that a reliable conclusion can be drawn about the sports watching preferences of all people in the town? Excuse me. So, sample size and population size, those are A and B. So we have to determine if that's something that really matters or not. So it's talking about a certain large town. That's your population. That's the big picture. But that really doesn't matter in regards to this particular survey. Sample size is also something that really doesn't matter. Yes, they polled 117 people from a local restaurant. So that would be your sample. But the number of people that they're polling is not really anything to worry about. Okay, so the number of people who refuse to respond, 7 people refused to respond, but that is nothing compared to the 117 people who actually partook in the survey, sorry. So C would not be it either. So that only leaves us with D, and it's talking about where the survey was given. So if you're talking about watching sports on television or attending a sporting event, well, if they're sitting at a restaurant on a Saturday, most likely they're not attending the sporting event. Okay, so that definitely would have an effect on your sample. So for number 24, it says the member of a city council wanted to assess the opinions of all city residents about converting an open field into a dog park. The council surveyed a sample of 500 city residents who own dogs. Okay, this right here, own dogs, is important. Okay, the survey showed that the majority of those sampled were in favor of a dog park. Which of the following is true about the city's council survey? So the reason this is biased already is because of the fact that these people only surveyed people who had dogs. So if you have a dog, most likely you wouldn't mind having a dog park for your dog to go play at. Okay, so it says, which of the following is true about the city council survey? So it shows that the majority of city residents are in favor of a dog park. I wouldn't say that it shows the majority. It only shows a one-sided opinion. It shows the opinion of people who have a dog. So A would not be it. The survey sample should have included more residents who are dog owners. Well, we already have a very large sample of people who are dog owners, so we don't need any more. So B would not be it either. The survey sample should have consisted entirely of residents who do not own dogs. So that wouldn't be fair either. That would be kind of biased the other direction. So if you don't own a dog, what's the need for you to have a dog park? So I would say it's not C either. So let's look at D and see why D, let's see what D has to say. It says the survey sample is biased because it is not representative of all city residents. That would be why, okay? It's only representing people who own dogs. It's not representative of anybody else, okay? So D is definitely the correct answer for number 24. Let's see. It doesn't look like we have any more. So that's all about samples and surveys and bias and all of that. So the main things that I want you to take away from this lesson are the fact that bias is just asking or giving a sample in a way that sways people in one direction. Okay. And then I also want you to understand the difference between a sample and a population. So like I said, if we sampled the entire school but only took the people on the second floor, our population would be the entire school, but our sample would just be the people on the second floor. So our population is our big picture and our sample is our smaller picture. Okay, so that is all for lesson 4. And if you have any questions, make sure to ask your teacher